Hi everyone, welcome to Trigonometry Part 2. Today's the first lesson of Part 2. We're going to be introducing trig equations today. So our trig equations, usually we're going to solve a first or a second degree equation, meaning it's going to have an exponent of 1 or 2 max. There sometimes may be a restricted domain, and restricted domains can be written in the format of 0, theta has to be greater than or equal to 0 but less than 2 pi, or so this is either in set notation or interval notation. We'll usually try to stick to interval notation. We also write general solutions for many of the possible solutions or many possible equations. That means we're basically writing down all possible coterminal angles. Right away we have example 1 here, and it says to write the following using interval notation. So clearly this is some sort of domain that they gave us, and we're just rewriting it into interval notation. So the first one here I have is going to be rounded bracket -2 comma 5 square bracket. Square bracket meaning we're including the 5. Rounded bracket means we do not include the -2. Over here we have square bracket -180 degrees all the way up to positive 180, square bracket again, because on both we have an equal sign, so we're going to include both. Over here we have from 0 to pi, rounded brackets on both because there's no equal sign under either of them. In example 2, we have some steps that you may follow to help you solve for the angle. And notice here it says determine the angle, or angles plural, meaning that sometimes there might be more than one answer. Given the following, solve for theta. So what do? So we have some steps. So step 1, draw triangles in the appropriate quadrants using the cast rule. Determine the reference angle using inverse trig, and then determine the actual angles in standard position. Okay. So first things first, double check that we have our calculator and we're in the right mode. So if I'm ever trying to find an angle, I do want to be in degrees mode there on my graphing calculator. So for this first one, here we go. So I'm looking for sine theta when it's equal to root 3 over 2. So first off, my hint here is when is sine positive? So what I'm looking for is, again, I'm going to sketch out my quadrant system, set up my cast rule, and look for all quadrants where sine is going to be positive. So let's quickly jot down. We have C, A, S, T, cast rule set up. Sine's going to be positive in 2 sections, and again right now my angles, my lines actually don't really matter how they look, but I am just going to draw a line. So sine is positive in quadrant 1 because all things are positive in quadrant 1, and sine is also positive in quadrant 2. Okay, so I'm going to draw an arrow in quadrant 1, quadrant 2, nothing for 3, nothing for 4, because those are where sine are negative. So what we want to do is solve this triangle. So the way I do this is I could set up a small little triangle right here, line straight down, and we're ultimately looking, and there's a line straight down over here as well, and we're ultimately looking for theta. So let's label this theta right in here and theta right in here, and that should be the same angle on both. Okay, same reference angle for both. So step 1, I drew out my appropriate triangle. So I have 2 triangles, one on the left, one on the right, both in quadrant 1 and quadrant 2. Step 2, determine the reference angle. So for me to determine the reference angle, I'm going to go sine inverse of root 3 over 2. So really this is theta equals sine inverse of root 3 over 2. So theta equals, and I'm going to go straight to my calculator. I'm already in degrees mode, so sine inverse of root 3 divided by 2 there. So I get an answer of 60 degrees. So therefore, our reference angle in this particular example is equal to 60 degrees. And by the way, RA stands for reference angle. So if I have a reference angle of 60 degrees, I could draw it into my picture here and here. So 60 degrees would go right in here for theta, and 60 degrees would go right in here as well. The question is, in standard, what are my 2 angles? Well, I have quadrant 1 and quadrant 2 where I have two angles. Theta here in standard is going to be 60 degrees. Over here, if I wrote down 60, that's my reference angle. That's not my standard angle. So standard meaning starting from your positive x-axis and going all the way around. Well, starting from my positive x-axis, going all the way around to this line here, if I got there and I added 60, I get to 180. So the question is, what is that line? That line in quadrant 2 is equal to 120 degrees. In this case here, I have my answer in degrees, but really we're looking for an answer in radian because we have a domain restriction between 0 and 2 pi in terms of radian. So let's just convert both of these back into radian. So this first one here, pi over 3. Second one here, 2 pi over 3. And there we go. That's our first example. In the next example, again, I'm going to start off by drawing out my lines. And let's see if I can redo that properly. Okay, let's try that again. Okay, there we go. And again, I want to superimpose my cast rule right on top. So CAST, and let's see what this question is asking us to do. We're looking for whenever cos theta is equal to negative. Well, cos is negative in two quadrants. The quadrants where cos is negative is in quadrant 2 and quadrant 3. So I'm going to draw two lines in quadrant 2 and quadrant 3. So there's my line in quadrant 2 and a line there in quadrant 3. And again, my lines are just lines. It's not accurately drawn by any means, but I am trying to draw them in the proper quadrant. From here, I do want to find the reference angle, which is going to be here and here for theta. And then find my two angles in quadrant 2 and in quadrant 3 in standard position starting from that positive x. So drew my shape, or drew my two triangles, that is. Let's find the inverse. So theta is equal to cos inverse of negative 1 over root 2. And going straight to my calculator again, if I do the inverse of cos negative 1 divided by root 2, there we go. I get 135 degrees. If I sketched on 135, that means from here, our positive x, to this first line here, that's 135 degrees. The question is, what's our reference angle? So our reference angle in this case here is going to be 45 degrees because we're already at 135. We needed 45 more degrees to get to 180. So reference angle 45 degrees. That's going to come in handy when we're trying to find our answer in quadrant 3. So basically our answer in quadrant 3 is going to be 180 plus the reference angle 45 there. So we're looking at 225 degrees. So let's write down our answer. So we have our answer in quadrant 2, and the answer there in quadrant 2 is 135 degrees. That's going to be our angle. And in quadrant 3, we ended up at 180 plus 180 plus 45 is 225 degrees. And notice our domain restriction is between 0 and 360, and so both of these fit in our domain restriction. In the next example, here we want to look for where tangent is negative. So which quadrants would tangent be negative? So let's sketch this out really quickly. Again, I'm going to superimpose my cast rule, CAST, there we go. And the quadrant where tangent is negative is in quadrant, let's do our line, quadrant 2 and quadrant 4. So I'm just going to draw a line down from 2 to 4. There we go. And we definitely want to find our triangle. So again, always triangle going to the x-axis. Okay, And so we want to find our reference angle, which will be the same reference angle for both of these. So first things first, let's go inverse tan. So theta is equal to tan inverse of -1. So theta here is going to equal -45 degrees. So -45 could definitely fit right in here, or let's figure out our reference angle. So our reference angle has to be 45 degrees. So I can write in 45 right here, and a little 45 right in here. So I have a reference angle 45, 45. So if I know in quadrant 2, I have from standard, which is 0 here, all the way around to this line here, plus another 45 to get to 180. That line there has to be 135 degrees. In quadrant 4 there, a quick way to figure out your answer would be going 360 minus 45, and you'll get to this exact same line because 45 is our reference, that line being 315 degrees. So again, our answer right now is in degrees. We want an answer in terms of radians, so let's just convert these over to radian, and you'll end up with 3 pi over 4, and this bottom one is 7 pi over 4. There we go. Last but not least, let's sketch out this picture. And don't mind the colors, I can just switch them up right now. There we go. So we're looking for where cos theta equals 0. Well, cos theta is equal to 0. That's going to be an actual coordinate, so let's write down some coordinates. So here we got 1, 0, 0, 1, -1, 0, 0, -1. And here, where cos theta equals 0, we're in two positions. We're right here, this vertical line right here, which is in two positions. So we can say that we have a reference angle basically of 90 degrees. But theta in this case here, so theta is equal to cos inverse of 0. That's going to be equal to, and I should have highlighted it for you, so we're looking right down here. This line right there, that's what we're looking at. So here, cos inverse of 0. That should have been 90, which it is 90, so theta is equal to 90 degrees. Down here, that's exactly on our y-axis still, so that's going to be 270 degrees. So we can say theta is equal to 90 or 270 degrees. There we go. In terms of radian, this is pi over 2 or 3 pi over 2. There we go. And that was just simply done by converting these angles. In the next example here, it says determine the angles given the following. So right now we're looking between 0 and 360 given this angle here. So first things first, let's find theta. Theta is equal to the cos inverse of 0.876 . And there we go, we get 28.8. But we usually round our angles to the nearest degree, so this is approximately 29 degrees. So if we have an angle of 29 degrees, we want to do a quick sketch here. We're looking for where cos is positive, even though that's not a nice number there. We're looking for where cos is positive. So CAST, so cos is positive in 1 and 4, quadrants 1 and 4. We know that the reference angle here is 29. We also have a 29 down here in quadrant 4. So we can say quadrant 1 is equal to 29 degrees. And in quadrant 4, we're equal to 360 minus 29, which is 331 degrees. In example B here, we can rewrite this here. So again, reminder, secant is the same thing as saying 1 over cos. So this is 1 over cos theta is equal to -5. So again, wherever cos is going to be positive, secant's positive. Wherever cos is negative, secant's negative. So let's do our quick sketch. Superimpose our cast rule on. And we're looking for where cos is negative. Well, we only really have two quadrants where cos is negative. It's in quadrant 2 and in quadrant 3. So that's where cos is negative. And I apologize for the difference in colors, but that's okay. And of course theta, reference angle, right in there for our quadrants 2 and 3. So if we go right away here, let's quickly rewrite this. This is the same thing as saying cos theta equals 1 over -5. So theta is equal to cos inverse of -1 over 5, which in this case here, a bit of an ugly decimal, but that's okay. Cos inverse of -1 over 5. 101.5 is our angle, so theta equals 101.5 degrees, but again, always rounding to the nearest whole. So we're looking at approximately 102 degrees. So if our reference, if not our reference, but if our angle here is 102, our reference angle we can find out. So our standard angle in quadrant 2 is 102. Our reference angle, let's find that out. So reference angle here is equal to the 180 minus 102. And we're going to need reference angle for quadrant 3 there. So that's why we're doing this. So 108 minus 102, that's 78 degrees. So therefore in quadrant 2, we're equal to 102 degrees. And in quadrant 3, we are 180 plus 102, so we are now at 258. There we go, degrees. And in this case here, they wanted our answer in terms of 0 to 2 pi, so I'm just going to convert both over. And in this case here, because these aren't the nicest angles, I'm just going to convert them to approximate values. So this is approximately 1.78 rads or radians. And over here, 4.50 if I rounded radians.